Imagine an object so powerful that it traps light itself. An object so strange that the known laws of physics stopped working at its core. These are not science fiction villains. They're real. And they're lurking all across the universe. Welcome back to WAWild, where we dive into the mysteries of space and science. Today, we're plunging into the abyss of black holes. What are they? How do they form? And what secrets are they hiding about space, time, and maybe even reality itself? A black hole isn't literally a hole, and it's not just empty space. It's a region of space where gravity is so intense that nothing can escape. That gravity comes from an incredibly dense core called a singularity, matter compressed into an infinitely small point. The boundary of no return is called the event horizon. Cross that invisible line and escape becomes impossible. Not because you'd be trapped by walls, but because even light, the fastest thing in the universe, gets pulled inward forever. From the outside, it just looks like pure darkness. Most black holes form when massive stars run out of fuel. A star's life is a battle between gravity pulling in and nuclear fusion pushing out. When fusion stops, gravity wins. The star collapses inward with catastrophic force. If it's big enough, about 20 times more massive than our sun, this collapse doesn't stop at a neutron star. It keeps going until the core is so dense that it becomes a black hole. But that's not the only way. Some black holes, called supermassive black holes, sit at the centers of galaxies. We're not sure how they formed. Did they grow slowly over billions of years, swallowing stars and gas? Or were they born huge in the early universe? At WAWild, we love these cosmic mysteries, and this is one of the biggest. Stellar black holes are a few to maybe 100 times heavier than our sun. Intermediate black holes are bigger, thousands of solar masses, but rare. We've only recently started to find hints of them. Supermassive black holes are true monsters, millions or billions of solar masses, shaping entire galaxies. The black hole at the center of the Milky Way, Sagittarius A, has a mass 4 million times that of our sun. And then there's the hypothetical primordial black holes, tiny ones that might have formed right after the Big Bang, smaller than an atom but incredibly dense. Let's get dramatic. What if you fell into one? If you approach feet first, gravity at your feet is much stronger than at your head. You'd stretch out like spaghetti. Scientists actually call this spaghettification. From your perspective, you'd fall straight in. But here's where things get weird. To someone watching from outside, you'd seem to slow down, dim, and freeze right at the event horizon. Time appears to stop for you. At least, from the outside viewer's frame of reference. Inside the event horizon, all paths lead inward. Space and time effectively switch roles. Moving forward in time means moving closer to the singularity. What happens when you reach the center? Physics, as we know it, simply can't describe it. That's why black holes are such a cosmic mystery, and why we at WAWild love exploring them. Here's an even bigger puzzle. According to quantum mechanics, information about the state of matter can never be completely destroyed. But when something falls into a black hole, it seems to vanish forever. So where does that information go? Stephen Hawking showed that black holes can slowly evaporate over enormous timescales through something called Hawking radiation. But if they eventually disappear, does the information vanish too? This information paradox is one of the deepest unsolved problems in modern physics, and solving it might require a new theory of gravity and quantum mechanics combined. At WAWild, we love when science breaks its own rules. Black holes aren't just cosmic trash compactors, they're engines of galaxy evolution. Their enormous gravity powers jets of radiation that can stretch for thousands of light years. They help regulate star formation in galaxies. And when black holes collide, they create ripples in the fabric of space-time, gravitational waves, that we can now detect with instruments like LIGO and Virgo. Every detection gives us a new window into the invisible universe. So what are black holes? Are they bottomless pits, gateways to other universes, or clues to a deeper reality we haven't yet unlocked? Whatever the answer, one thing is clear. Studying black holes doesn't just tell us about them, it tells us about the entire cosmos, and maybe even its ultimate fate. Thanks for watching WAWild. If you enjoyed diving into the darkest objects in the universe, hit that like button, subscribe for more cosmic adventures, and tell me in the comments, if you could safely visit a black hole, what would you want to see on the other side?